helps customers to navigate their explosive growth using the technology, and we are the technologists. We help customers to scale their users about hundreds of millions and scale their revenue to about more than $1 billion. We have open and closed source thought leaders in our company and experts, and we have a couple of people who wrote books. So I learned about Postgres from one of the book wrote by Robert Treat, who is my colleague. That's great. So we provide a full stack solutions using a multidisciplinary DevOps approach, and we have different teams, database teams, operations team, web ops team, and designing user experience team, and we work all together to solve the business problem. So today I am going to talk about scalability, definitely, because that's the title of the talk. How you can scale the Postgres, it's vertically or horizontally, obstacles to scalability and Postgres. So what is scalability? So a service is defined as a scalable system when you increase the resources in the system and it results in increase in performance in manner of proportional to resource added. So those three keywords: increase in resources, performance, and proportional to resource added. And why to scale database? Like why? We need to support higher number of users. Like you always, why the graphics is not working? That's fine. Provide better performance to existing users, store a large volume of data, improve system availability, and geographic dispersion of the data. So these are the some of the reasons that you might come across the need for scaling your database. And why database scalability is so hard? Because I think all other IT stack solution, I think you always talk about web scalability, all other things, it's really, I think you can easily found the solution, but for the database scalability, because of some of the reasons, you need to make sure you put your blocks right. Search is the big problem, right? Some of the customers comes to us like, everything works fine in the application, but search is slow. Please help us. Concurrency, we used to have only 10 concurrent users, now we have 1,000 concurrent users. Consistency, okay, I started my database and now I have consistency problem. Okay. Speed, the query used to run really fast. It used to take 5 milliseconds, now it takes 10 or 15 seconds. But what changed? Your data grew. And cost associated with scaling the database. That cost could be hardware cost, could be deployment effort, ongoing maintenance. So those are the things are really hard problems. So as I mentioned earlier, what are the scaling needs? Data growth. So I think you should define your needs whenever I work with the customer, whenever there is a scalability problem, I try to find out, is it a read heavy database versus write heavy? Because once you understand your data needs, then you can able to provide the solution depending on your needs. So make sure you find out from your application or database that is it really read heavy or write heavy application or a mix of both, and you can approach accordingly. And there are two ways, you can scale up, it's a vertical scaling, or scale out, it's a horizontal scaling. So I am going to use the refrigerator example. I think it's funny, it came in my mind last week, so I had to change my slides later on. But for example, you bought a refrigerator for your apartment, and once it's filled up, like you want to add more stuff into it, like there is no space, so you need to buy a bigger one. If you are in the apartment, then I don't think so you have a good space to put another refrigerator in the apartment. You might buy a house for that, or maybe I don't know, like it's scaling vertical, like how big you can buy the refrigerator, and then you bail out. On the horizontal scaling, like you buy cheaper refrigerator, couple of those, maybe 3, 4, 5, and then you can add more stuff in it. So that's how you scale your refrigerator. The similar way you can scale your systems too. Like you need to think like it's a normal thing, like scaling your refrigerator versus scaling your systems. Okay, so let's talk about some of the pros and cons about vertical scaling. So simple to implement, right? I need to buy only one refrigerator. I can go shop, maybe go to Costco or somewhere and buy the cheaper one and bigger one, and I can add more stuff. Ease of maintenance, right? I have to just think about the space for one refrigerator. I don't need 3, like otherwise your wife will not allow you to put the 3 refrigerator in the kitchen for sure. Cons. Cost of hardware, like once you scale up, like you're getting bigger and bigger one, the cost will be accumulating because the bigger is much costlier than the smaller one. And sometimes SPOF, like single point of failure. What if a refrigerator goes down, where you gonna put all your stuff? Maybe you will go to your neighbor's place, maybe relative's place, I don't know. So that's the problem with the vertical scaling. Horizontal scaling. We got 3 refrigerators now. So let's think, what are the pros? If overall, like proportional to whatever I can store in those three refrigerators, the overall cost is cheaper because I have more space, and I will definitely go buy the cheaper one because now I have 3. If one of that goes down, then I have others too. Flexibility, that's the flexibility, right? Because you can have number of those. Higher fault tolerance, one of goes down, then maybe two of them goes down, you still have another one. The cons, complex to implement, right? Because I am in apartment and I think I can't have 3 refrigerators in the apartment, but if I am in the house, then I can put one in the kitchen, one in the first floor, another one somewhere in the garage, and I can scale vertical and horizontal. Expensive to maintain because there is a cost associated, like the energy cost and all those, like you got to keep that running and maintain too, right? Because you need to shuffle around the things, like the most important stuff you have to keep here in the main refrigerator, that's in kitchen, then the extra will go into garage, and the important one that will be useful during the night, it will go into first floor. And bigger footprint in the data center. Data center is our house, right? You will see refrigerator all around, like you will rename your name to the refrigerator house or something like that. And no built-in support in databases. So there is no support, like in the databases, like the databases I work, like Postgres, like there is no built-in support for, like you can do scale out for your write request directly. So there are some pros and cons. Okay, so if you are going to implement a new application or new project, or you have existing application that you're going to run on the Postgres database, this is like speccing the hardware is really important thing, because your scaling will dependent on your hardware spec, whatever you choose. Omnity I do hosting for the clients as well. So normally, because of the things are little cheaper compared to the previous days, we usually go with CPU 8 plus cores. RAM, I think you should get as much as possible, but we try to go at least for 64 gig plus. 128 is good, 256 is really good, 512 is really good, 1 terabyte is awesome. Disk, I think all of our data centers now use SSDs. So how many of you are not using SSDs? Not using SSDs? Okay, you should go buy SSDs first. Sure, definitely. So and RAID 10, if you are not using SSD, at least you should use RAID 10. I think it's little costlier than RAID 5 or other options, but RAID 10 is the best options for databases. And network, minimum gigabit or 10 gigabit if you can afford it, but yeah, that's the speccing of hardware. Like, make sure you spend money, like you don't have to worry more about the CPU, it's more about databases, more about RAM and the IO. So you should spend your money wisely. Okay, so once we have hardware in place, now we would like to tune the Postgres. Like, you can't run Postgres without tuning your postgres.com file. Never ever run that. Like, even though you don't need a scaling, make sure that you tune your postgres.com file. So first of all, I am going to go with the memory parameters. I am not going to spend more time on it, but if you have more question, you can meet me after the talk. But it's shared buffers, like by default it's really small value. So you can go with 4 gig, 8 gig, or up to 20% of the available RAM depending on your need. It's really depend. We had a one of the system had 100 gig of shared buffers, and we migrated to 9.2, and now we have about 4 or 8 gig. So it depends on your need and how your data growth. If you can put everything in your database in the shared buffer, that's cool. Effective cache size about 70 to 75% of your RAM. Checkpoints completion target 0.9 is the good value to set without asking any question, but I know your manager is going to ask why it's 0.9 not 1. So it's I'm going to point to the another wiki page that you can go ahead and convince your manager that it should be 0.9. Checkpoint segments, you can start with 100, and then depending your on the need, I am going to talk about like how you can log your checkpoint segment, how checkpoints, then if your system is giving warning, or if you are doing too frequent checkpoint segments, then you should increase that. Maximum connections. So yeah, that's the big problem. Like, even though it's with a small application, people just set it 1000, even though they just need maybe 100 or 200 maximum connection at a time. So I think maximum connection settings is related to other memory parameters too. So make sure you gather the requirements for the required connection settings and you set that. Work mem, I usually start with 1 MB or 2 MB. Maintenance work mem, that's useful for vacuuming, so how fast the vacuum can work, and that can be set maybe 4 or 5 depending on your need, but make sure you tune that. And there is a wiki page I was mentioning earlier. You can go to that wiki page and understand why we are setting these things, and that will be useful to convince the manager, because it's going to be in the change management. So and I am going to share the slides afterwards too. Okay, so now we tune the Postgres count now. So whatever application, software, whatever you are working, make sure that you are logging it appropriately, because without logging, I think you can't know what it's actually doing. Like, you can't understand the need for scaling. Some of the things logging can provide, I think you can't find anywhere else. So, and it's really good tool that can be used for the analysis, and you can use to understand your database growth and database patterns. Logging collector on, log destination, I don't have any preference where you log it. Wherever you log it, log it. Log file name, this is like standard we use at OmniTI, like we rotate the logs after probably 10 megabytes, so it's like day, time, hour, minute, seconds. Log line prefix is really important to set it properly, because that will allow you to parse your logs to the tools that I am going to mention in the next slide, that can be used, and it's really useful to set it right. To get like percentage %m, it will give you the milliseconds precision in the log. Log minimum duration statement, it's 1000 milliseconds is 1 second. So it will log all the queries that takes longer than 1 second. You can set according to your need, but set it some value that makes sense to you. Log auto vacuum minimum duration statement, that will log your auto vacuum daemon process, like how long does it take to vacuum the tables. Like, for example, some of the tables takes long period of time because it's a really large table. So, and you might be able to correlate the performance issues during that time. So you might have to tune the auto vacuum process to run during some time, or maybe log weights is on. So that will log the logs weighted for the processes. So make sure you turn it on. Like, these are the things are very useful when you are having issues with the databases and you need to tune the things, or maybe find out the debug the stuff, like why it's slow. Log temp files will log all the temp files generated during the query. Log checkpoints, that's what I mentioned earlier, like that will log all the checkpoints like every minute or 5 minutes. Log connections and disconnections should be on. So if user complains you, like I was connected and my process is stuck, so you can find it out when the user was connected to database, then what he or she did on the database, then when it disconnected. So you can have a complete life cycle of that connection. Log minimum error statement, it will warning, it will log the from warning, error, panic. Log minimum messages, warning, error, panic. And log statement is DDL. So this is really important. Like one of the incident we have, like somebody changed something in the production and we had this turned on, so we could able to go back and see, like about a week ago person named C did this stuff, and should be able to correlate that event. So log statement DDL, it's I think by default it's turned off, so you should turn this on. Okay, so I have a logging turned on now. Postgres conf is set, hardware is there. Now even though if you are not having issue, like whenever you set up the new system or existing system, if you have it, then make sure you set up the PG Badger report. You can set up, PG Badger is a tool that can be used to parse the report, and log line prefix, that's what I mentioned in earlier slide, that could be useful to parse those logs through PG Badger, and it will create really nice graphical HTML reports. It will have overall statistics, the log file name, how many line parsed, start time, end time, and most queries report, like which query you was ran most frequently, and which one is the slowest query of the day, something like that. For one of the client, we run every hour actually to make sure, and we email them as well, like every day we get an email, like it's a short form of email that we just send out the slowest query, and it will be in dev's email box and DBA's and ops email box too. So everybody could see that these are the slowest queries. Even though not everybody is going to read that, it's really useful to keep eye on it. Extensive monitoring. So if you are using Nagios or any other tool, make sure you incorporate, like you are always monitoring, like its system is up, you should make sure same thing for the database as well, like database is up, what are the statistics for the database, similar to how the RAM is used. So we use Circonus. So this is the graph. It doesn't look nice, but that's fine. I'll just tell you what it does. Like it just trending the sequential scan versus index scans. So you can see in the graph, like if you see the spike in the sequential scan, I think you should go in your log file, and maybe you can run during that hour and parse that log into PG Badger and analyze that log and see like why the query is doing sequential scan. And that's a really nice way to monitor the database. Explain, analyze, like once you found like there is a query, it's doing a sequential scan, so explain, analyze, like there is a arguments you can pass, the buffers, analyze buffers, that will show you the buffers shared hit statistics as well. So you can run that and see like is it using index only scan, or is it doing bitmap scan or something else, or merge join. My colleague Dapaze has an open source tool, like it's online, explain.dapaze.com. It's really nice tool. Once you have explain, analyze, you can just copy paste here and it will generate reports like this, like even though you are not technical, like like a manager, not my manager, I can't say that, he is here, okay. So sorry about that, but it will show you like where it is taking long time. So and it's really nice tool, you can use, like try it, like it's really, you can anonymize your report so nobody else can know that what was the query report will look like. So it will rename the table name, you can actually run on your system as well. Track functions. Track me if you can. I think some of the business logic we incorporate that into functions. So it's really good idea to track the runtime for the functions, because one function can run multiple queries inside. So it's really good way. There is a config parameter that allow you in Postgres.conf, you need to, it's by default is none, but you can set all on PL. PL is good enough, so you can track all your functions, and you can reload online, so you can change it whenever you need. Select star from PG state user functions. Once that is enabled on your Postgres.conf file, you can view the statistics in this view, and that will give you this, like function name, schema name, calls, number of calls, total time versus self time. Self time is the actual function time. The total time is the time for somebody is calling a function, so it's total time to return. If you are running a couple of functions in the transaction, then it will be total time during that transaction. Okay, so I think we did everything we could able to get most out of our Postgres database. I think we have monitoring in place, we, we now do logging analysis, we have a good hardware in place, we have good DBS in place. So now even though there are some couple of times, right, like couple of tables, those are always grows really fast, like users table or maybe transactions table. You always find at least 4 or 5 tables in the application that grows really fast. Even and that slows down, that actually slows things down. Even with adding more indexing, it doesn't help you. So next logical step you could do is like you can partition that table. So it could be on maybe a date or maybe on the ID if you can, like. So I think you need to choose your partitioning key wisely as well. Like if you don't know your data, I think you can't able to define the partitioning key. So make sure you understand your data. Partitioning pruning queries, like there is a option constraint underscore exclusion. I think Postgres 9 plus it's turned on by default, but if you are running older version of Postgres, make sure you turn it on, constraint underscore exclusion, and you should query accordingly. Like if you have partitioned by timestamp, then if you are going to query for before 5 years ago and you are not using the partitioning pruning in your application, then it could be a problem. Like it is going to scan all the tables in that partitions, all the partition tables, and get the results. So I think if you are doing a partitioning, so you should try to use partitioning pruning in your application. And I think new features come with some responsibility, so you need to manage your partitions. Okay, so how the partitioning works in Postgres? There are two types of partitions, like in Postgres provides list partitions and range partition. In list partition, like as an example, like there are 3 regions, then you have East Coast, West Coast, and Central Coast region, then you can partition accordingly. On the range partitioning, you can partition by date or ID. You can partition by like per month or maybe the users after X number. And Postgres provide 2 approaches for partitioning. Like you can use partitioning using triggers or rule based, but never ever use rule based partitioning. It's old school now, and it used to have problems, and it has a problem with more locking during the partition maintenance. So it's we always prefer to use trigger based partition. The problem is like there is no built-in Postgres partitioning management in core. So my colleague Keith, he wrote a partition management extension pg_partman that we have been using for number of months now, and with a couple of clients already with about thousands of partitions, and it works great, and it can help you to manage your partitions. If you want to know more about it, actually you can download from pgxn first, and if you want to know more about it, tomorrow there is a session at 11:30 a.m. The talk title start with when Postgres can't. So there is nothing mentioned about pg_partman, but he is going to talk about it. So go if you want to learn about pg_partman. So now we partition the table using partitioning method like list or range. If there is other way to partition your table, because once you know your data, I think you can partition logically, like some of the data is not related to other data. For example, there is a configuration data, there is a transaction data, there is a session data that you don't want to have, like there is no foreign key relationship with anybody else, then you can store on the separate Postgres clusters, or you can start with a separate schema first. It's a logical partitioning, and then there is no relationship between data, so you can move out of that from schema to the different machine easily. Oops. Yes, help. Okay, help to spread the load across the server. So it helps, and less complex compared to the sharding. That's we are going to talk next, probably. The other tool is PG Bouncer. How many of you never heard about PG Bouncer? 1, 2, 3, 4. Okay, so everybody is expert in PG Bouncer. So I'm just going to scroll really fast about it. It's a PG Bouncer is a tool that is a lightweight connection pooling. Connection puller. It helps to reduce the connection, newly created connection. So it can reuse the connection depending on your. There are 3 options provided by PG Bouncer, and other than that, it abstracts the DB from the apps, because your application will know only about the PG Bouncer, not the database. So your application connects to the PG Bouncer, and your PG Bouncer will connect to the database. So in case of failure, you fail over your database, and then you can just reload your PG Bouncer config file to redirect the request to the new database that you just failed over. So this is really nice tool for the failover purpose, for reducing the connections, because making a new connections are expensive. So if your application is making a lot of connection, I think this is a really good tool to explore. And it provides connection pooling options. It's session, transaction, statement. By default it's a session pooling mode, but it doesn't provide a lot of benefit. Usually when you go to transaction pooling mode, it will allow you to reduce number of connection. Even the only problem with the transaction pooling mode is it doesn't support the prepared transactions. So if your application is using prepared transaction, you shouldn't use transaction pooling. You can still use the session pooling mode, and you might get some of the advantages like DB abstraction and all other, the failover and all of those. Caching. So we did everything now. We have PG Bouncer in place. We tuned our queries. I think what you are missing is caching. You can use whatever caching tool you want to use, but we prefer to use open source one. So one of that is your application server. It's a memcached. You can your application can connect to memcached and RDBMS. That's our Postgres, and it's a really nice tool for a caching purpose, like in-memory caching. So that speed up the application because it alleviates some of the load from the database to serve some of the queries, some of the data like read-only queries or something like that. So, and there is another option is Redis. It's a new, I think memcached is the old one. So you can use any of those, like it's advanced key value store, and it works in memory and in persistent layer. But if you are going to use with the caching, I think in memory should be enough, and I think it allows you to do some kind of munching with the data structure too. So that might be useful if you are looking forward for that. I think you can search on the Google for Redis, and whatever, like as I said earlier, whatever the caching you are using, make sure you are using the caching layer somewhere, before the application points to the database. Caching is really important part of it. Replication. Okay, so first I am going to talk about built-in replication that is provided by Postgres code. In that, there are like cluster level replication, like binary replication. So streaming replication, for example, that you can stream the WAL files directly to the replicated server. You can have a cascading too, right? You can have a master, secondary too. So it's really nice feature. Postgres added Postgres 9 plus the streaming application. And there is WAL only replication. Like there are still some of the use cases you can use WAL only replication. Like for example, we have used WAL only replication for different region for replicating your Postgres, because whenever we run a Postgres on the Amazon cloud or any other cloud, we try to have 3 servers, like one is the master, read slave 1, read slave 2, read slave 2. Sometimes we set it up as a just WAL only replication. You can just send out WAL files and then the WAL files will be applied. Hybrid replication, and most of our client use hybrid, like it's both. We do streaming as well as WAL shipping. So in case streaming breaks, like WAL shipping, WAL can allow you to catch up the replication. So I think all of our clients use hybrid replication. We use streaming and shipping the WALs. Master failover, it's slave 1, streaming. So OmniPITR is the tool that we wrote to manage the WAL files and replication, and it allows you to take a backup on the slave. There is a lot of talks available online if you are interested to learn about it, and it's an open source project if you want to contribute. So we have OmniPITR on all those servers, and the WAL will be managed, and now we manage the backups as well. So some of the pros. Built-in, it's built-in, like once you install Postgres, it's available. You don't have to, like in Oracle, you need to buy the license. There is no licensing cost here. Like once you are installing Postgres, streaming replication is available to your desk. Now it's up to you, you want to use it or not. Allows to open replicated database in read-only mode, because some of the application, some of the queries, like very long running queries, you can use, you can open up your read-only slave for those queries. So that will offload some of the load from the production database server to that reporting, you can say as a reporting, like reporting server. The cons, all or none. So you replicate everything or nothing. That's the problem. For example, you have 3 databases in the Postgres cluster, and you just one database is really important, other 2s are not important, and you don't want to replicate because it's just a session data. There is no way you can do through streaming replication. So it's all or none. Doesn't allow write on the replicated database. So your replicated database, you can't able to write even temp tables. There is no way. So it's just a read-only database. Doesn't work across major version. Like you can't replicate from 9.2 to 9.3, but you can replicate for minor version. You can replicate from 9.2.1 to 9.2.4. So it's really nice tool for upgrade minor version. Like you upgrade your secondary database first. Using PG bouncer, you can move out, fail over to the secondary and flip PG bouncer config to point to the secondary database, and then upgrade the primary production database. I think Selena did this probably. She created binary replication tools wiki page, that there are a number of those, like 4 or 5. So you can choose one of that but I would prefer if you choose OmniPITR. Just saying. Replication. Okay, there is new tool just available in Postgres 9.3. We have a data warehouse system. You have a read slave 1. I think I had a discussion this morning with Jignesh, like he was mentioning this. You can use Postgres FTW. It's a foreign data wrapper. So I mentioned that like there is no way you can open your database, the replicated database in the read write mode, right? Because it's just a read only replicated server. In using this method, what you can do is you can write a Postgres FTW and point to the read slave. You can fetch all the data in the data warehouse system. This data warehouse system is the completely independent cluster running on 9.3, and that will allow you to copy the data. Like you just need couple of tables or maybe 10 tables. You don't want to replicate everything from that database. It's really nice tool, so you can choose and select whatever tables you need. So it allows you to access the data stored across the different Postgres server, cross version queries. So Postgres 9.3 could query 9.1. So if you are bringing up a new cluster, because the good thing about Postgres, it's free, right? Because I used to be Oracle DBA about 6 years ago, and I have to bring up the Oracle, like there are a lot of things you need to think about, like first is cost. So here like you can just bring up the new server and set up Postgres 9.3 instance, install Postgres FTW, point to the read slave, and you have kind of reporting database ready. Its application is like run query remotely on slave DB. Even you can run remote queries and data warehouse data refreshes. Like this is really, it is going to be a really good tool for refreshing your data warehouse data. Oh, still we have application, third party tools, maybe fourth party tools. So we have gone, no, it's trigger. So all of the third party tools are using trigger based, like they are putting trigger on the table and tracking your insert, update and delete, and allows you to replicate your replicated database. Slowney, who never heard of Slowney before? Slowney, okay, we can talk about later. Bucardo, that's another tool that you can use. Mimeo, that's the tool we wrote recently, probably a couple of years ago, for the replication purpose. And Pros, yeah, so it allows your replicated database to open in the read write mode, because it's a trigger based. Some of the systems are pull versus pull. It's just pulling the data from the production database, putting into the, and it's almost real time, like there's some lag, about 5 minutes of lag, but you can replicate your entire database or table. Sometimes like it allows you to rolling upgrade, like you bring up the new database in the 9.3, you set up the Slowney or Bucardo or Mimeo and on 9.3, and then you just fail over to the 9.3 and then upgrade the production database. Its cross version replication is allowed. I think Bucardo is multi-master replication as well. I think Slowney and so, but the problem is complicated to set up, because if you don't know like what you are doing, then I wouldn't recommend you to use like one of that, because sometimes it's really problematic to debug the issues it has, and unknown territory. So yeah, still there are a lot of users of Slowney, Bucardo and Mimeo. Like you can get a support of it, like if you are really into trouble, there is community around it. Sharding, how many of you are using sharding on your production environment? No, I don't. Oh, my manager is, he's a technical guy. Okay, so yeah, sharding. Sharding is like you just split split up your data into the separate tables or mostly in the different physical servers. So you shard based on the users, like from this shard, from this user ID to this user ID is going to stay here, something like that. So there are different ways, there are different shard keys. So there are, from my perspective, this is nothing like in the book. Like from my perspective, there are two types of sharding. One is the application aware sharding, and next is the application transparent sharding. So the application aware sharding is like your application knows where is your data, and your application needs little bit of modification to know like where your, so where to talk to find the right data. On the application transparent sharding, you don't need to change any application, you just point to the cluster and the database will know it's a sharded. So application aware sharding, the way I wanted to give the entire talk on the sharding, but then like I thought like sharding is really complex, and it's we usually don't recommend directly to a person like let's do sharding. Like if you don't know your data, I think sharding can screw you up. Instagram does really nicely. If you haven't read of the blog, there is a blog, and I think there is a presentation already there on the online, like Instagram, search on Google Instagram sharding. The way they are using Postgres for sharding. So Postgres, how they did is like they allows Postgres has a schema. So they started, there were only 2 servers first, and each cluster has like 1000 schema and 1000 schema in another system. So they first sharded logically. So you don't have to buy expensive hardware like maybe 1000 server to start with. You can shard by schema, it's a logical sharding, and then later on you can move to the actual physical server depending on your load. That's where the monitoring and query tuning and all those stuffs come into picture. Like if you are monitoring your system, then you know how to, where to move and when to move the sharded schema, and easy to move the physical shards later. Application transparent sharding. Okay, hold on your breath. Okay. Postgres XE. Postgres XE can allow you to have like a application transparent sharding. I think there's a talk today, probably. There is you can attend if you are interested learning about it. It's little bit of complex system, but if you know the basics how it works, I think you can able to figure it out. But this is the architecture of Postgres XE cluster. So yeah, that's what I said, like sharding is your last step. Like even though like most of the time, like if you are running probably up to 5 terabyte of database, usually you don't need sharding, but after that there is a need. Sharding challenges, I think reliability is the problem, because you need to manage lot of systems around it, and it's distributed queries. Like you need to query, if you want to do joint queries and all those stuff, then you need to query from all the shards and combine the results and provide the results back. Auto increment key management, like the Postgres auto increment thing doesn't work with the sharding. Like you need something different, because auto increment on the cluster is global for that database. So you are using in the schema, then we probably choosing a shard key is a real problem. Like if you don't know how your application is going to react to the sharding, I think you should rethink over like why we should shard. Like you should spend more time thinking about how to shard compared to implement the system. I think there are number of case studies out there that you can use and choose once you decide that you want to shard. And shard schemes, there are different schemes, like you want to generate that shard key in the application or in the ticket server, or I think Instagram did something differently. So if you know like what you are looking for, then I think then go ahead with sharding. So now we're going to talk about obstacles for the scaling Postgres. Postgres table bloat is the problem. Like there are tools available that you can run to unbloat or maybe remove the bloat from the tables and indexes online. Uh, uh, foreign keys relationships is a problem. If you are having a lot of foreign keys in your system, then like functional partitioning and sharding, and you are limited by that a little. Insufficient logging, like as I said earlier, logging is really important part for scaling. So if you are not logging enough, then I think you should start logging. I think it will not cost you a lot compared to how much revenue you can lose because of you don't have enough logging, because whenever there is a problem and you want to debug the problem, logging is really important. Caching, insufficient caching is the problem too. Like if you are not doing caching enough, it will put more load on your system, your database systems. Insufficient monitoring and metrics. There are a lot of open source and closed source and SaaS based solutions available like Janos and Circonus and Nagios and Graphite and what else? There are a number of those. ORMs, like ORMs sometimes like you need to be careful about it. Sometimes it makes your difficult to read the query. So ORM might be difficult to debug the problem right away. Single point of failure, like you shouldn't run any of your system shouldn't be SPOFs. Mainly for database, like always use replication or something that can replicate your data at least on site or off site somewhere. And lack of communication between teams, because scaling is not only from one perspective. I think multidisciplinary teams should work together to achieve the common goal for the business. So beyond Postgres, like database is thing like you want to scale, but I think you should look beyond the Postgres from the application perspective too when you are thinking about sharding or not sharding, scaling. So avoid serialization in your application code. If your application is serialized, like this can't be done without this, avoid, try to like some of the time like that could be a problem with the concurrency. And feature flags is really important, like most of the time scalability is a problem with one part of the application, not other parts are working really nice. So because that feature is really, this is, we just introduced features and everybody liked it and our system wasn't good enough to handle the load. So have in your application a flag that you can turn on or turn off, or sometimes you can eventually put more and more user, like turn on the feature only for these users. So it's really nice tool for scaling. Browse only mode, like if you are starting a new application, I think it's really difficult to change your existing application, but when you are starting a new application, it's really important that you understand that there will be a need that you want to just open your application only for read only. So make sure your user gets the right error message when somebody is trying to modify the things. So this can be useful during the upgrade. Right now Postgres doesn't allow the rolling upgrade feature, so but I hope there will be one sometime. So but right now if you want to upgrade it, like you can fail over to the read only replicated slave, and you can use that. Don't use databases for queuing. Use the right tool or whatever tool you think is right. For example, RabbitMQ, or don't use for like Postgres a queuing system. Reconsider option for full text search. Recently I found like there was a client just came for the scaling consulting help, like they were doing a lot of I like and like queries. Instead of that, you should try to use like research provided by Postgres, or you can go use like different tools, Solar or Lucene. So it's really important that you understand use the right tool for right problem. Further reading, you can have like there's a couple of books I just throw it out. Postgres 9 High Performance by Greg Smith, Web Operations by John Alspaugh, Jesse Robbins, Scalable Internet Architectures, Theo Klasnagel, that's our CEO. And references, these are some of the references I used during the talk, so if you are going to download the talk, then you might be interested. And thank you for Postgres Open Committee for allowing me to have a talk and share some ideas here. And thank you OmniTI and my manager for being so nice to me so far. And thank you for being here. If you have any question, I am open for any question. We have 3 minutes, but I will be roaming around here, so you can just snap me. Yes.
What I know, I've just been reading about sharding, and I've read it about doing it through PL proxy and I guess Sky tools, and everything suggests that if I go that way, I'm giving up everything has to go through stored procedures. No ORMs, no ad hoc, and I hate to do that. Am I right? And does that
Yes.
apply to Postgres XC also?
Postgres XC, I'm not sure about Postgres XC. Like, no, I think.
You think I could still get away with ad hoc?
I don't think so, because you still need have those stored procedure in Postgres XC too.
Oh, okay.
So I think that's the reason. Like, I like to have application aware sharding, so you know, like we implemented sharding once right now. Like V means I, just using the ticketed server. Like you go to the DB ticket server, and then your application will go there and find the right shard. That's how like Instagram did little bit differently, but it's really nice the way they keep it simple. Like, I don't like the complex solutions. That's only me, or I don't know, but yeah, PL proxy, we looked into it, but we didn't like it. Any other question? Okay, thank you.